Let's begin. So before we go into this tutorial, a few things that we need to remember, okay, about transistors. Number one, okay, we have to remember the function of a transistor, or at least the working principle. Okay, the working principle of a transistor. Okay, basically, when does a transistor work and when does it not work? Okay, so the underlying principle behind the working principle is that the supplied voltage, or the base voltage, or the voltage in the base circuit, okay, must be more than the junction voltage. Okay, and if you watched yesterday's video, okay, you will know that junction voltage is very dependent on the type of semiconductor that you use. If you use a silicon semiconductor, it'll be 0.7 volts. If you use a germanium, GE, if you use a germanium semiconductor, it's 0.1 volts. But the idea is this lah: the bigger your junction voltage, the bigger your base voltage, okay, it should be bigger than the junction voltage. Okay, once you have a big enough junction voltage, then you will be able to, then the transistor will work. And then we looked at the uses of the transistor in two places. Okay, the use of transistor the use of transistor as number one, as an automatic switch. Okay, and then secondly, as a current amplifier. Okay, and we find that one of the biggest uses for the transistor is in an amplifying device lah. For example, a sound amplifier. Okay, when you speak normally, but this microphone over here is amplifying my sound so that it becomes a bigger sound. So it does that by using a lot of transistors lah, okay, to help. So in the current amplifier, the working principle is when the IB increase, okay, the IC will increase a lot more. Okay, and we talked about this snowball effect last week. You change a little bit in the current of the base, okay, and then the current of the collector will change a lot. Okay, then when we talked about automatic switch, we looked even further into the automatic switch by looking at two ways to use the automatic switch. Okay, one is to combine the transistor with a light dependent resistor. Oh no, what is this? Sorry, light dependent resistor, or LDR. Okay, and then the second one is by using the thermistor. Okay, and both of these, okay, is high resistance when it is dark. Okay, and this one is high resistance when it is cold. Okay, so when it is dark or when it is cold, it is high resistance. And then the place where we position the resistor, okay, the light dependent or the thermistor, okay, tells us where the place is lah. Sorry, hold on. It tells us where the it tells us which part of it will function. Okay, so if you put the thermistor up here, okay, then it depends on which situation you want. You want high temperature, low temperature. So all these four diagrams, I think there are 6 altogether, right? So this 1, 2, for the thermistor there's 2, but for the LDR there's 4. Okay, LDR there's 4 because you want to know whether you want to turn on the bulb during the daytime or during the nighttime. So the position of the LDR and the position of the thermistor, okay, can change depending on the situation that you want. Okay, so it's very important that you remember. Of course, the most important thing to remember is the two conditions. Okay, the resistance of the LDR is high when it is dark, and the resistance of the thermistor is high when it is cold. The part of the divider where the resistance is high will experience a big voltage. And if the big voltage is in the base circuit, then the transistor will switch on, and so on and so forth lah. Okay, the progression is always the same. It's just where the resistor is. that determines which part is going to be high resistance and low resistance. Again, depending on the time of the day and depending on the temperature of the situation. Okay, so what you should be avoiding lah. Okay, one piece of information, one piece of advice that I want to that I want to advise you is don't memorize the position. Okay, because the position can change, right? No, if let's say this question say the position like this, and then the next question I put the thermistor down here, okay, the position can change. What you need to be remembering is when does the thermistor or the LDR have a high resistor? When does it have a low resistance? Okay, that will help you to think about the flow. Okay, high resistor means high voltage, means the base voltage should be more than the junction voltage. If it is more, then it will flow, switch on, and then the alarm will go off. This is very, very easy. So only these two can probably change. Okay, it can interchange. Sorry, I don't know what I'm doing. Okay, it can interchange very easily. So be very careful with this. Okay, don't memorize the circuit. Don't memorize the position of the thermistor. Rather, memorize what happens, during different situations. Okay, which now, because of that, now we can go into the thermistor. But basically, that's it lah. Okay, paling pun ada satu formula saja, which is the voltage equals to V1 equals to R1 over R1 plus R2 times the total V. This is the potential divider circuit formula. Okay, all right. Wow, the good news is number 1 and number 2 has already been answered for you. Okay, so this is an NPN transistor, and you know this because the arrow is going down. Okay, so P will be the base, Q will be the collector, and then R will be the emitter. Okay, BCE lah, base, collector, emitter. Okay, number 2, which of the following shows the correct name for the electrode P? This leg is the emitter lah. Okay, and the type of transistor will be PNP because the arrow is going in. Okay, so yeah, sorry, unfortunately I tekan the first two. Okay, let's go to number 3. Which statement is correct about the transistor? Let's do this alphabetically, please, because I'm lazy to switch back and forth. So let's start with Adam.
D.
Okay, D will function as an amplifier. 2 electrodes is wrong. 2 electrodes is a diode. Okay, and it's interesting that there is a word die over here. Not die as in mati die, but die as in double lah. Okay, diode is 2 electrodes. Have you thought about it? Okay, dual electrode. Okay, OD and then DU. Okay lah, fine lah. It should be duode bahkan, but no, it's not. It's diode. Okay, just like DCPIP, right? Is dichlorophenyl di lah. Okay, double lah. Okay, that's what it means. Okay. Okay, number 4. What are the electrical components that must be placed in P and Q? Sini P, sini Q. Wow. Oh, okay. Oh, that's so interesting. Okay, Eliska?
C.
All right. Okay. P will be resistor and Q will be battery. This is a potential divider circuit, just to remind you. Okay, potential divider. Pembahagi voltan. Atau pembahagi upaya lah, because potential is actually beza keupayaan. So potential divider in Malay is called pembahagi upaya, but it is also usually known as pembahagi voltan lah. Why am I in green color? So strange. Hold on. Okay, red. All right, next question. NPN is connected to DC supply. Which of the following is correct? Who's after Eliska?
B.
Sorry?
B.
B for boy. Did you say boy or dog?
B.
Boy, Okay. IE is more than IB is more than IC. Oh, okay. Unfortunately, okay, that is incorrect. The good thing is you make sure that the IE is the biggest lah. But actually IC is always bigger than IB. If you remember, I mentioned before, IB is usually in the microamps and IC is usually in milliamps, which is much bigger. Okay, of course, IE, the emitter current is the combination of IB and IC. So the good thing is you got the first one correct. Okay, but the order is very important. Okay, IC is always bigger than IB. But again, I'm saying this, a change in IB will cause a huge change in IC. Okay, so IB amplifies. Okay, IC. The current in the base will amplify the current in the collector. And it doesn't work the other way around. Okay, so the IC cannot affect the IB. It cannot. But the IB affects the IC. Okay, we spoke about this last week. All right. Okay, number 6. Next person, please.
A.
A. Okay, why A? Who is this? Brandon? Oh, yeah.
Because it's NPN transistor.
Because it's NPN transistor. So, actually the important one is
the battery.
okay, fine. So tell me how the battery, okay, and the CB junction is connected. That is actually what determines the this one. You don't remember?
Junction voltage.
I know. Okay, fine. The junction voltage is here. Okay, let me draw it a little bit bigger. So this is the N, and this is the P, right? Okay, so this is the base. This is going towards the collector. Okay, but the battery is disambung begini. Okay, I'm drawing these dotted lines because there's another N here. But when we consider these two only, how is this and this? Apa dia punya jenis sambungan? What is the type of connection here? Do you know what's the right word to use? Okay, it's okay. So the N diode, sorry, the N semiconductor is connected to the positive terminal of the battery. Manakala the P is connected to the negative terminal of the battery. So it is reverse bias. And manakala in this one is also reverse bias. No, in this P and N is forward bias. Kan? So the BE is forward bias and the BC is reverse bias. BC is reverse bias and then the BE okay, is forward bias. As long as the BE is forward bias, okay, your circuit will light up. Itu yang paling penting. The BE junction must be forward bias. Because if this happens, okay, then the electrons can come here and then it can pass through, okay, because of the base voltage. Okay, so again, reminding you that when we talk about diode, when we talk about transistor, and if I ask you a question about what is the type of connection, apa jenis sambungan, okay, you need to be thinking about the words reverse bias and forward bias. Reverse bias is negative sambung kepada positif, positif sambung kepada negatif. Forward bias is, the other way around. And in a diode circuit, diode sahaja, okay, in a diode circuit, only when the diode is connected in a forward bias, then the current will flow. Okay, so this is where we remember all these things. Okay, number 7. Next person. Damir.
B.
Voltage divider.
Boy.
Oh, ball. Okay, good. Amplifier. Nampak amplifier because it's loudspeaker. Okay, so the function of transistor is loudspeaker, then microphone. Ini memang kau nampak sudah amplifier. Rectifier memang out of the question lah. Rectifier is guna diode. Okay, dan ada dua jenis rectifier which is half wave and full wave. Okay, half wave is one diode. Aiyo. Okay, full wave is 4 diodes. Okay, so rectifier memang out. Automatic switch mungkin berlaku, tetapi disebabkan there is a loudspeaker and a microphone kan, doesn't really work as an automatic switch. Automatic switch kita mau on off. So if I put a bulb over here, then it will probably be a automatic switch. Voltage divider paling out lah, because if you want a voltage divider, there has to be a resistor over here and then another resistor over here. Don't even need this battery source. Okay, so definitely tak boleh. Alright, good. After Damir is Daniel, number 8.
A switch.
Sorry?
B, a switch.
Okay, B, a switch. Alright, this will function as a switch lah, because the moment you see light detector or thermistor, okay, you're talking about switch. You want to on or off something secara automatic. Actually, this is not even technically correct. It should be an automatic switch. Because a switch is kamu masih kena tekan bah. Okay, but an automatic switch is you don't have to tekan anything. Actually, it is the light detector resistor that is doing its job. Okay, the light detector resistor will increase the resistance so that the junction voltage blah 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 blah. Okay, an automatic switch is the better word for this. Okay, number 9. Elijah.
B.
B. Okay, interchange R1 and R2. This one is the switch will light up at night. Okay, so this the light dependent resistor is here. Actually it should be this. Okay, but if you want to light it up during the daytime, you just change the place. Okay, you reverse the terminals of the battery, it doesn't work. Because if you reverse the terminals of the battery, the transistor will switch off. I mean, it's not even connected correctly lah, so tak boleh. This is an NPN, right? Okay. Replace the NPN transistor with a PNP transistor also doesn't work, because it doesn't matter whether it changes position. Replace resistor R3 with a resistor of a lower resistance. Not necessarily. Okay, definitely. This one doesn't have much to do lah. Okay, it is this one that is mainly doing its job. Okay, what is the reading of V2 when V1 is 1.5 volts? Oh, it is very, very simple. Next person, please. I think it's Ava. No, Ava is not here. Udina.
B.
Okay, it will be B. Okay, 4.5 volts. And we know this because, again, I say point to point. Okay, if this is 6 volts, this point to this point is 6 volts. This point all the way to this point is 6 volts. This point all the way to this point is 6 volts. Okay, but in between the 2 points, if the voltage can be divided because it is a series circuit. Okay, so remember, voltage is divided in the series circuit, but the current is the same. So we did this in chapter 3 lah. Okay, just to remind you. All right, is that all the objective questions there are? Okay, fine. Diagram 7 shows a light dependent resistor RS. Oh no, R and S, here's a transistor, here's a battery. Look at how what kind of sambungan is this battery? So strange. Okay, the LED emits lights when it is bright surroundings. Okay, state the function of a transistor. This one I would ask somebody lah. Okay, so the function can either be an amplifier or automatic switch. Okay, so dia tidak banyak. There is not really much answer to this. At least at Form 5 level lah. Okay, we only learn 2 functions of a transistor: to amplify current or to work as an automatic switch. Okay, diode is. Somebody asked me this question the other day. What if I say the diode is to rectify, is to convert the alternating current to DC current? That's one function. Another function is to allow the current to flow in one direction only. Okay, so these are the only functions of a diode. Okay, quite easily to remember. Of course, it's good if this is the only thing that you have to study, but there's more than there's 12 chapters. How many? There's 13 chapters of physics altogether. Wow. Okay, complete the diagram 7 so that the LED emits light in the bright surroundings. All you have to do is just complete everything, except that I think this battery dia macam salah. It should be actually positive and negative over here. Kan ini macam salah tempat lah. Okay, so actually this is really nothing much. Just kasih complete saja lah. Okay, complete. This is like, okay, mari kita main sambung-sambung. Okay. Alright. Done. Kan? Wah, kan bagus kalau soalan SPM begini kan. Main sambung-sambung saja, habis. Okay, give one reason. Okay, why the LED emits light in a bright surrounding. Can I have Jacinta for this?
It has low resistance.
It has low resistance when it is bright. So, okay, sorry, actually it's true lah. The LED light emits light in the bright surroundings because of number one, the position of where it is lah. Okay, so it's going to turn this LED light, okay, to turn on when it is bright because of where it is. Okay, think about this. Now you're talking about bright bahkan. Kalau bright, resistance of LDR is low. So resistance low, voltage low. Okay, if the voltage here is low, here the voltage will be high and melebihi the junction voltage. So base current flows, collector current flows, transistor on, LED switches on. Okay, remember in a divider circuit, kalau satu voltage rendah, satu voltage mesti tinggi. Okay, and when it is tinggi, we always assume that it will be higher than the junction voltage. Okay, and that's why the current can flow. Now, so Jacinta's, this one was correct, but you said it, okay, because it has low resistance. The it is actually wrong. It is the LDR that has the low resistance. Okay, when there is light, the resistance of the LDR decreases. Just now you said it, so I was like, it. Nothing to do with the LED. The LED, the function is just to, pasang lampu saja. Okay, and LED is such a, please forgive the pun, but LED is such a lit word nowadays lah, because everybody wants to buy LED lights lah. So more pasang that, what is that light the one that you put along the ceiling one? Okay, that one whole line of lights and terus menjadikan kau punya bilik macam disco, like can change color, green lah, white lah, purple lah. Okay, I can't remember what's the name of the light lah. But what is low resistance is actually the LDR. Okay, the light dependent resistor. This is the full answer, but for only 1 mark, it's a little bit doing lah. Okay, for me, this is enough because the resistance of the LDR decreases. Okay, well, if you want to give a complete answer, go ahead lah. Voltage across LDR decreases, voltage across R increases, base current flows through S, therefore the collector current flows, the transistor switch on. Okay, that flow is always there. Okay, the flow is always there. Base current flows, collector current flows, transistor switch on, LED bulb or whatever it is, your bulb lights up. Okay, the flow is always there. You just have to remember it. Okay, so what modification is required to the circuit so that the LED will emit light when the surroundings become dark? What do we need to change about this so that I want it to pasang kalau time gelap? Jericho. No, Jericho's not here. Crispia.
Interchange R with LDR.
All right, very good. Okay, we interchange R with LDR. Wow, jawapan skema betul. Interchange lagi dia letak. I would have actually switch the position of R with LDR. Yeah, not because I like Ariana Grande, but I wouldn't use the word interchange lah, because to me interchange is like train station. Okay? Stesen kereta api. Get down on this platform to interchange with another station. Okay. That for me is interchange lah. Okay, anyway, merepek lah pada waktu pagi ni kan. Okay, an alarm is needed which emits sound when there is a fire. 2 modifications have to be made by replacing the electric components. State 1 electric component and needs to be replaced. Definitely this needs to be replaced. Lester.
change the LDR with thermistor
Okay, change the LDR with thermistor. Why? Because you have the
because the thermistor has lower resistance or higher. Wait. Because the thermistor has higher resistance when it is cold.
Yeah. Okay. No. Low resistance. Eh? You see, even I forget. Hold on. I wrote this somewhere. High resistance when it's cold. Okay, fine. You're right. Because the thermistor has high resistance when it is cold. Okay, that is one answer. Okay, although there's actually only one electronic component that needs to be replaced. But yes, there are actually two answers lah. Okay, and I think you should take note of both. Although you only need one lah. Okay, number one, of course, you change the LDR, okay, to the thermistor. And why? Because it is not sensitive to heat. Number two, you have to change the LED to an alarm. Okay, because we need an alarm. There's no point if there is a fire and then lampu hidup. What's the point? Can you imagine if you have a fire alarm, and then when there is a fire only, then the lights will come on. Okay, what a tragedy your life will be if that happens. Okay, if you have a fire alarm, the word alarm, okay, emits sound. Okay, must be there. It has to have a speaker. If no alarm, okay, you can also put a speaker. Okay, a speaker, generally in physics, when we talk about speaker, dia kalau ada litar kan, if there is current flowing, it will automatically keluarkan bunyi, walaupun it's called a speaker lah. Okay, but of course, the better word is alarm. So you, like Lester said just now, you change the LDR to thermistor. Okay, and the reason that you gave just now is actually perfectly fine. It has low resistance when it is, it has high resistance when it is cold. Yes, it has high resistance when it is cold. Okay, resistance is high when it is cold or low temperature. Okay, but another one that you need to change is the LED. In this particular example answer they gave, we change LDR because the LDR is not sensitive to heat, and we change the LED because the LED doesn't produce a sound. Unless you create an LED, a sound producing LED. That means got light and got sound at the same time. So it becomes like a disco show like that. Okay, also can lah. All right. Question D, name two electronic components that are used to replace the unsuitable component. This has been touched on, so I'm just going to answer straight. We change the LDR to thermistor or heat-dependent resistor, and we change the LED to a siren or an alarm, okay, or a bell. Okay, like the fire alarm bell, ring, the one very long one. That one also. This one lah. Okay, in the space below, draw a circuit diagram to show the new circuit. Now, so the biggest difference is that in this one, okay, we have to move the LDR down here if we want it to light up during the dark. Okay, but in our case of the thermistor, okay, we have to draw the heat-dependent resistor up here. Okay, and then you change the LED with this one. Now, what if, and this is a very common question I get, what if I forget to draw this resistor? Okay, what if I forget? Sebab saya terlampau focus on these two resistors. So this is the voltage divider resistor. Ini sebenarnya tidak terlibat. This is just in the base. This is in the base circuit. Okay, litar tapak. So only these two resistors are actually the more important ones lah. So let's say in the exam, you forget to draw this S. Okay, so my answer will be, this is actually for me, I think it's not such a big problem for me lah. Okay, for me it's not such a big problem, but I am not an examiner. Okay, and so I can say this only with a 50% certainty lah. I think that this, if you forget to draw this resistor, it will greatly depend on how strict the marking is in that particular year. Okay, I have heard that there are some years where they are so strict that if you forget this S resistor, you will be minus 1 mark lah. So you only get 1 mark. But some years they will say, oh, never mind, no S also, never mind. This is the more important one. Okay, so I really cannot say with any certainty that it's okay to forget the S, but I would probably advise you to just remember that there's an extra resistor lah. Okay, because the added resistor plus with this high resistance, okay, will give the base voltage, okay, to be more than the junction voltage. Okay, but of course, again, like I said, the most important thing is the position of the heat dependent resistor. Ini yang lebih penting sebenarnya. Okay, if you forget the S, it's risky, but try not to forget the S lah. Okay, but if you forget, then hopefully that particular year, the marking scheme is not so strict lah. Okay, and I think if you ask me, I think don't take this as the truth lah. Okay, but I think that maybe for your year there will be a little bit more lax lah, because number one, you are the first batch of SPM people to sit for the very new format. Okay, that's number one. Number two, your exam is in March lah, for goodness sake. Okay, your exam is in March. Enough lah, okay, enough of difficulties kan. Bagus kalau diorang ada kesian dengan kamu lah. I cannot say for certain lah, okay, but I really hope that they will be a little bit more relaxed with you all in your SPM next year lah, kan? Amin. Okay. Next, question number 4. Name the resistor X. What is this resistor called? Louis.
LDR.
Okay, it's correct. LDR. Dalam bahasa Melayu, in Malay it's called PPC, Perintah Pekercahaya. And generally, if you just give the short form, it's okay. It's generally accepted. You don't have to write light dependent resistor. Of course, that's a much nicer answer. But if you forget what LDR stands for, okay, just like LED lah. You know, what does LED stand for? LED is light emitting diode. Okay, but most people don't remember what is the meaning of LED. They just remember, oh, ini lampu LED. Sebab sangat famous kan lampu LED sekarang. Yeah, so not so important to remember the design, but remember the short form. Okay, and those of you who want to know, in Malay, it's called Perintah Pekercahaya lah, light dependent resistor. Okay, calculate the potential difference between T and U, sini dan sini, if perintah X adalah 40 kilo ohms apabila dia berada dalam keadaan gelap. Sorry, why am I reading Malay? Resistance of resistor X is 40 kilo ohms, okay, when it is dark. Okay, can you calculate the potential difference, please? Whoever is next. Melanie.
Yes. Sir, mau change dulu kah dia pergi?
Yes, must.
Oh, okay.
Must change, guys. Must change. Okay, to 1,000.
40,000 divided by 50,000 times with 6. So the answer is 4.8 V.
40,000 over 50,000 times with 6. The answer is
4.8
4.8 volt. Okay. Teruskanlah Melanie, since you're here. The current, please. When we want to calculate the current, use Ohm's law. V equals to IR. Tapi hanya
okay.
Hanya
6 divided by 50,000.
Okay, 6 divided by 50,000. Okay, fine. 6 divided by 50,000. Sebab, kau mau mengira semua kah? Okay, fine. Equals to?
0.00 0.012 M.
3 zeros. 1, 2 M. Okay. I think can. Hold on. Okay, you will get these two answers lah. Now, let's say because you see the resistor X sahaja kan. What if I use 4.8 divided by 40,000? because the voltage that is running here is 4.8 volts, yang kau sudah kira, and the resistance is 40,000, you will also get the same answer. Okay, 0.001200012 amps. Okay, but what Melody is doing over here is she's considering the whole thing lah. Okay, because remember, in a series circuit, the current is the same. Whether it is flowing through one resistor or both resistors, okay, the current is the same, except that kalau kamu mau pertimbangkan kedua-dua resistance, then you have to take the entire thing lah, from point to point. Okay, now let's just do a short recap. If this is 4.5 volts, I hope that you automatically know that the voltage running through here is 1.5 volts. Okay, it must be automatic by now lah. Okay, because remember, point to point is 6 volts. Okay, so 4.8 volts and then 0.00012 amps. Actually, my calculator is showing 1.2 times 10 to the power of -4. -4 amps, yeah. Also can lah. Okay, so again, guys, look at this. Very, very small. Okay, very, very small base current. Okay, which causes a big what's this called, collector current. Okay, actually this is not even micro, this is like so it's 12 milliamps. Okay, wow, so this is milli. So if this is milli, this will be ampere times 10 -3. Yeah, this will be ampere. Wow, so cool. Okay, sorry, saya cool sendiri saja. Diagram 4 shows a circuit with a transistor that acts as an automatic switch. Explain why the LED lights up when the resistor is in the dark. Oh no. Okay. Most important thing is this lah. The resistance of the LDR is high when it is dark. Okay. This is the most important thing. Resistance of LDR is high when it is dark, and because of that, the voltage of the LDR will be high. Because of that, the base voltage will be higher, okay, or exceed the junction voltage. Can you please include these words in? I know that this answer, they just cakap base voltage is high, but I want you to make it a habit that when you talk about high, okay, it must be high enough lah. Kalau dia tinggi, tetapi tidak cukup tinggi, what's the point? Okay, there must be a certain thing to compare it to. So the base voltage. Okay, the base voltage exceeds, okay, the junction voltage in the transistor. This is a better answer. Okay, daripada just the base voltage is high. Okay, talk about the junction voltage. Definitely your answer will be very cantik. Okay, when the base voltage exceeds the junction voltage in the transistor, the base current will flow. When the base current flows, you know what happens? Collector current flow. When the collector current flow, transistor will switch on. And when the transistor will switch on, the LED will light up. Okay, so you see this pattern again and again and again and again. Okay, after a while it's like, astaga, bosannya. Okay, it's actually very boring. All you need to know is, okay, is the voltage higher than the junction voltage? If the voltage higher than junction voltage, base current flow, collector current flow, transistor switch on, LED lights up, or alarm berbunyi, or whatever it is lah. Okay, whatever it is yang kau letak di sini lah. Okay, kalau dia mental. Kalau dia microwave oven will hidup. Wow. Okay, I wish that would happen. All right. Question B. Diagram 12.2 shows an amplifier circuit. Okay, explain how the circuit functions as an amplifier. Okay, the explanation for this is pretty long. Okay, so I'm just going to give it to you over here. Yeah, okay. So the microphone converts the sound waves to alternating current. Okay, and the capacitor helps in this lah. Okay, now the alternating current combines with the base current. Okay, and the transistor will amplify the base current, because remember, a small change in the base current causes a large change in the collector current. Okay, so actually there is already base current flowing. Okay, there is already base current flowing, but when you speak into the microphone, okay, the microphone changes the sound waves to alternating current. and it will add on to the base current. Okay, and remember the snowball effect. You change the base current a little bit, okay, you're going to change the collector current, a large change in the collector current. And so the loudspeaker will convert the AC current to sound waves. Okay, so meskipun kamu berbisik di dalam microphone, in the loudspeaker, it will be much louder. Okay, it will be much louder than the bass. Sorry, the what you spoke lah. Okay, and remember the amplification. Just a reminder of the formula. The amplification is the collector current over the base current. Okay, berapa kali ganda lebih besar. I think tomorrow I will continue lah. Okay, there's so many more questions and it's all. Oh, okay. These are important questions now. I don't think I should skip this. Okay. Okay, what you can do is you can prepare for tomorrow by looking at question number 4 to 8 lah. 4. There's no question 5 times. 4, 6, 7, and 8. But it's just that 6, 7, and 8 are very, very long questions. Yeah, sampai ada ABCD, ABCD, ABCD lah. But I think we should look at question 4, 6, and 8. 4, 6, 7, and 8 tomorrow. Okay. And these are essay questions. So it's a good idea for you to take a look at it. Okay.